All right, welcome back to the deep dive. Today, we're strapping in, quite literally, given our topic, and taking a serious look at something absolutely fundamental for anyone heading into aviation: climatology. We've got a stack of your sources here, articles, notes, all designed to give you a solid grip on global weather patterns, especially with those ATPL theory exams in mind.
Right.
Our mission: to dive deep into this material, pull out the most important insights, and basically give you a shortcut to understanding why weather happens where it happens around the world.
And that why is critical, really, for a pilot. Understanding the typical conditions you can expect in different parts of the world, how those conditions change with the seasons, and how things like, mountains or vast oceans influence everything.
Yeah.
That provides the essential context you need to anticipate weather, plan effectively, and really make sense of your forecasts. It's not just about what the weather is, but why it's likely to be that way.
Exactly. So over the next little while, we're going to unpack some really fascinating aspects of our atmosphere. We'll look at the big picture, the global engine driving it all, then drill down into specific wind systems, distinct climate zones, and even what's going on way up high where the airliners cruise. It's all in the sources you've shared, and it's all key knowledge. Okay, let's start at the beginning. The sources define climatology. What is it really?
Okay. So at its core, climatology is the study of global weather phenomena and patterns, but with the focus on the general conditions and the reasons behind them.
Right.
It's not about forecasting tomorrow's rain shower in one specific town. It's more about understanding why one region is predictably hot and wet year-round, while another is, say, cold and dry for months on end. It's the long-term average picture.
So it's the underlying system, and the sources list the key elements climatology studies, the building blocks of these weather patterns.
That's right. We're talking about the big five, essentially.
Yeah.
Precipitation, how much and when it falls; temperature, how hot or cold it gets; and the variations, daily and seasonal; humidity levels; sunshine, basically how much solar energy reaches the surface; and the prevailing wind velocity and direction.
Okay.
Climatology examines how these elements interact and why they differ so much across the planet.
And what makes them differ so much? What are the main controls, the factors that shape these elements uniquely in different places?
Well, there are several major factors according to the material we have here. Latitude is huge, obviously, because that dictates the angle of the sun and the amount of solar radiation received.
Access.
Then, whether a location is maritime near a large body of water or continental deep inland, that's critical too. It really affects temperature extremes and moisture availability.
Right. Land heats and cools faster.
Exactly. The large-scale circulation of the atmosphere's pressure systems, which, we'll get into detail on, is absolutely fundamental. Altitude changes temperature and pressure significantly as you climb. And finally, local geography, things like mountain ranges, large lakes, even the type of surface like a forest versus a desert. All these things modify the bigger global pattern.
So many factors.
Yeah, and understanding how these factors combined in any given location is what allows climatologists to predict general conditions, which in turn helps refine the short-term weather forecasting you rely on day to day.
So it's this interplay of vast global forces and specific local features. And the sources point to a main driving force behind this global engine, what gets it all started.
Yes, the primary engine, the thing that really sets the whole system in motion, is the movement of air within the troposphere. That's the lowest layer of the atmosphere where all our weather happens.
Right.
And that movement is overwhelmingly caused by the unequal heating of the Earth's surface by the sun. Simple as that, but profoundly important. The difference in how much energy different latitudes or different surfaces land versus sea absorb creates temperature differences. The temperature differences create pressure differences, and pressure differences make the air move. That's the fundamental starting point for everything.
Okay, so unequal heating is the spark. And this leads to the concept the sources call idealized air circulation. What's the point of looking at this sort of perfect model? It sounds a bit theoretical.
It is theoretical, but it's incredibly useful. The idealized...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best